Hello everyone. Myself Chaitanya Jays, currently pursuing my second year BE in the Department of CSE Civil in Sri Venkateshwara College of Engineering, Vidyanagar, Bangalore. Today I am here to explain about ANOVA techniques and basic principles. Introduction to ANOVA. ANOVA stands for Analysis of Variance, a statistical method used to compare means among three or more groups. These techniques helps us to determine if there are any statistical significant difference between a group means. It is widely used in various fields including psychology, medicine and agriculture. Basic principles of ANOVA. The core principle of ANOVA is to analyze the variance within the group versus the variance between the groups. It tests the null hypothesis that all the group means are equal against the alternative at least one is different. ANOVA assumes that the data are normally distributed and the variance across the groups are homogeneous. Types of ANOVA. There are several types of ANOVA, including one-way ANOVA, two-way ANOVA, and repeated measures ANOVA. One-way ANOVA compares means across a single factor with a multiple levels. Two-way ANOVA evaluates the impact of two independent variables and their interaction on a dependent variable. One-way ANOVA. One-way ANOVA is utilized when comparing the means of two or more independent groups. The test calculates the F statistics, which is the ratio of variance between the groups to the variance within the groups. A significant F statistic indicates that at least one group mean differs from the others. Two-way ANOVA. Two-way ANOVA accesses the influence of two independent variables on a dependent variable simultaneously. It also examines the interaction between the two independent variables. This technique can provide a more comprehensive understanding of complex data sets. Repeated measures ANOVA. Repeated measures ANOVA is used when the same subjects are measured multiple times under a different conditions. This method accounts for a correlation between the repeated measurements, reducing a error variance. It is commonly applied in a longitudinal studies and experiments with a time-based interventions. Assumptions of ANOVA. ANOVA relies on several assumptions for a valid results, including normality, homogeneity of a variance, and independence. Normality assumes that the data in each group are normally distributed. Homogeneity of a variance requires that the variance among the groups are approximately equal. Post hoc tests. If ANOVA results indicate significant differences, post hoc tests are conducted to identify which group differs. There are several most common post hoc tests. These tests controls from type 1 error while providing a detailed comprehension of group means. Applications of ANOVA. ANOVA is extensively used in experimental design, clinical trials, and surveys research. It helps researchers make informed decisions based on the difference observed in a mean of various groups. The technique is also valuable in a quality control and product testing and the industrial application. Conclusion. ANOVA is a powerful statistical tool that facilitates the analysis of group differences effectively. Understanding its principles and application is essential for researchers and analytics. Proper application of ANOVA can lead to valuable insights and informed conclusions in various fields for study.